Hello and welcome to my channel Quality Talks. In this video, we will be talking about a critical document that ensures product quality in manufacturing, that is control plan. Control plan is an essential part of the production part approval process or PPAP. Control plan takes input from PFD, that is process sequence, product and process characteristics, that is a part of design also, and PFMEA, potential failure mode effect analysis. A control plan is a detailed document that defines how we control and monitor the manufacturing process. A control plan is like a roadmap that is guiding us to ensure that products are made exactly to the customer requirements every time. The control plan tells us what to check, how to check, how often to check, and what to do if something goes wrong. Now let's look at the key elements that makes a control plan. First, the process step. Here we define what process needs to be controlled. Next, the characteristics. This defines what exactly must be measured, like a part's diameter, hardness or color. Then, specification and tolerance, which sets the acceptable limits for the characteristics. We also describe the measurement method, how the checking will be done. This could be using tools like a micrometer or a CMM or just a visual inspection. Another key point is sample size and frequency. This answers how many parts and how often should we check, for example 1 per hour or 5 per batch. Then comes the control method. It could involve statistical process control charts or 100% inspection. And finally, the reaction plan. This outlines what actions to be taken if the characteristics is found out of specifications, like stopping the production, quarantining the parts, or initiating corrective action like rework. The control plan is developed in 3 distinct phases: prototype, pre-launch and production. Prototype control plan. This phase is implemented when the tooling and processes are still in prototype stage. The main objective is to validate the product design. Since the processes are not yet mature, 100% inspection is typically required to ensure product quality. Pre-launch control plan. This plan is used when some production tooling and processes are available but not fully finalized. The focus here is on validating the manufacturing process. Inspection levels are reduced compared to the prototype phase but remains higher than standard production level, ensuring potential issues are identified early. Production control plan. This phase begins once all tooling and processes are fully developed and production is stabilized. The goal is to maintain consistent quality during regular manufacturing. Standard inspection methods such as gauging and sampling are used to monitor and control quality. Let's understand the structure of a control plan with this real case example. First, we have a title block. This is a title block of a control plan. In the title block, we have different type of information like part number, part name, revision number, the control plan type, whether it is a prototype, pre-launch or production. Now let's move to main body of the control plan. The first column is for the process number. In our example, the process number is OP30. The next is the process description. Here the process is described as final machining process. Following that, we mention details of machine and tooling. In this case, it is a BMC machine 03 and fixture number 450. Here in characteristics there are two columns, one is for process characteristics, other one is for product characteristics. In this example, from serial number 1 to 8 are the product characteristics and 9, 10 are the process characteristics. The next column is for special characteristics. Moving ahead, we define the product or process specification and tolerance. This sets the acceptable limits for each parameter. Like for the parameter number 3, CD, center distance, specification is 232 and tolerance is plus minus 0.3. Then we capture the measurement method, specifying how the parameter will be checked, whether through CMM, micrometer or visual inspection. In this case, for parameter number 3, it is CMM. Next, we record the sample size and inspection frequency. It indicates how many parts will be checked and how often it will be checked. Parameter 3 is being checked 2 pieces per shift. The control method comes next, describing how we ensure the process stays within the control limits. Then we assign responsibility, defining who is accountable for monitoring, and finally we define a reaction plan that elaborates what actions to be taken in the case of non-conformity. I hope this video is useful for you. Please provide me the feedback. Please subscribe my channel Quality Talks for more such type of videos. Thank you very much.